Okay, so, oh, really? Disconnect and I have to reconnect. Okay, is everybody ready?
Yep.
William? Okay. What is a nested query? A nested query is a query within a query. So there is an outer query and there could be one or more inner queries. So what happens is that the result of the inner queries is passed on to the outer query, and then outer query uses that result to generate the final result. So the result that you are getting is coming from the outer query, but the outer query is getting its result through the processing of the inner query. That's where things could get a little bit complicated based on the problem statement as to how you go about wording your inner query, how to return values to the outer query. And if you are returning, can I return one value? Can I return multiple values? And many, many things in that regard. For example, if you guys remember, I told you that we can write a query that can give us the maximum value of any book in the database. And how do you do that?
Just with the max.
Right, select
function.
max, retail, from books, right? That will do the deal, cut the deal, okay? However, if I tell you that I want to know the name of that book, that is the most expensive, you cannot do it like this, because if you do something like this, it will be an error. Why would this be an error?
Doesn't have a group by clause.
Exactly, and if I start doing group by clause, what will happen? It will start giving me all the books, because none of the book is like all the books are unique, right? So it will gonna give me the price of each book along with it. So it doesn't really cut the deal. Okay, similarly, if I say I want to know all those books, I want to view all books that are that cost more than average book cost of all books. Okay, so if you try to do something like this, select all books where the cost is greater than average cost. Will this do? Will this work?
No.
No. Why?
I think you still need the group by, right?
What do I need the group by for? I didn't include it any groups in the star. The problem is you cannot just mention a field on the right-hand side of the relational operator without giving it a context. So it doesn't really know, what do you mean average cost? So that's why it says use of function is not valid. So the only way out would be that the right-hand side is replaced with an actual SQL statement, which will calculate the average cost of all the books and will return that one value to the outer clause. And then the outer clause will use that value to then select all the books where cost exceeds that average amount. Do you guys follow that?
Yeah.
Okay. So now these are all the books that cost more than the average cost of all books. Now, based on the same principle, if I say select the titles of the books that cost less than the average cost of all books, okay? See if you guys can do this yourself. Okay, everybody got this? So what changes will I make to line 7 and 8 to achieve what I'm asking line 6?
Then just flip the operator.
And
That's it. Oh well, and did select title.
right.
So select star.
Okay. Now, let me switch this. I'll make some changes to this comment. Select the title of the most expensive book. Or whenever you guys are done, you know, I mean, like, give me a green check so I know that you're done. Okay. So what change will I make to line number 11 and 12?
Instead of 11, 12. 11 doesn't need to change, but 12, where cost equals, and then instead of the average, I did max.
Yeah. Cool. So select the title, category, and retail. So you simply can add more fields. Very similarly, if you want to do it for the least expensive book, then you will just change the max to a min. And that basically will do it. Okay. Now, let me give you guys a query to solve. Okay. Good morning, Mason. So Mason, we log into ACS and open run SQL script. We are working with nested queries right now. Thank you. So for those of you who are done, which is most of you, what should I write?
I I didn't see that one above. Um, what I wrote was in the nested query, I did select cost. Huh?
Yeah, go ahead.
Yeah, I selected the cost from books where the title just equaled database implementation, and then just compared that where in the outer query where cost is greater than that cost.
Okay. Okay, so these are all the books where the cost of the book exceeds the cost of the book title database implementation. So all these queries that we have done so far can let you write a query inside, and then the result of that inside query can be tested with some kind of a field in the outside query through one of the operators to then filter out the rest of the results. So for example, if we take this to real life, give me the list of all those students who has a grade point average more than the average student. Okay. Give me the name of the student or students with the highest GPA. Give me all those students who have the highest GPA in the so-and-so department. So there can be other implementation in terms of retrieving sales data and things of that nature. Okay. Good morning, Thomas.
Quiero.
So we are in the run SQL script on ACS. Okay. Now let me give you another query similar to this one, but not exactly the same. Okay. So most of you got it. So what should I write?
I just took the previous one and just tacked and category equals computer onto the end.
Oh, So these are all the books that cost more than the database implementation book. Is this what it is? Correct? Did I do it correctly?
I think your screen froze.
Oh, hold on a second.
Oh, there we go. Now it's good.
Is this correct or no?
No, it's out. It's in the outer
Very
query.
good. Okay. So, because I am selecting all the computer books in the outer query, now database implementation is just a title, all I need to figure out its cost. So give me the cost of this book and give me all those books that cost more than that book in the following category. So it's pretty much like I want to select all the employees that have done sales more than so-and-so salesperson, and the employees are in such and such group program, whatever. Okay. Okay. So next one could be a little bit more trickier, I would say. Let's see if you guys can figure this one out. Maybe Cameron's connection is unstable. Welcome back, Cameron.
Computer's acting funny.
Oh, I thought your Wi-Fi is kicking you off. Okay, so sometimes your Wi-Fi's act weird. They're asking you to restart them. So For those of you who got this done, what did you write?
I did, so instead of cost for both, I did, so in the outer query it was retail minus cost, and in the inner query it was average retail minus average cost.
Cool, cool. So you basically selected which field in the outermost query?
Title.
Title, okay. Where the difference of retail minus cost, which is the profit, exceeds the average profit of all books. So these are the books with the profit exceeding the average profit of all books. Okay. The next query, let's do the next query together, but we need to identify the tables involved in the process. This is what I want to do. I want to display the last name of the author of the most expensive book. So what tables will be involved? You have the entity relationship diagram on Blackboard under course documents.
All right, we have to connect books author and book author.
Books, author, and book author, the three tables, right? Okay.
Yep.
And do I need some kind of a nested query here?
Just like the most expensive book, probably.
Yeah. Okay. Okay. So we learned about this kind of stuff last week, where was it last week or the week before last week? When did we learn about joins? Inner join.
I think that was 2 weeks ago.
2 weeks ago. Okay. So we basically did something similar to this one in the prior classes. So what is the common field between author and book author?
ISBN.
Between author and book author?
Oh, sorry, it's author ID.
Author ID, okay. And between the book author and the book? Books?
That's ISBN.
That's ISBN, okay. So we need to select the last name from...
I think it's just L name.
Is it L name? Oh, okay, thank you. L name from books B, inner join, book author on B.ISBN equals to BA.ISBN. Okay, what should I write next after that to connect to the next table?
Probably a where clause.
No, I need another table.
Okay, then another inner join.
Another inner join, right? Okay.
Right.
So
Okay.
I need inner join author A on BA.author ID equals to A.author ID. Okay. Let me also alias my field A.L name. Okay. Now you said where clause? Where? Retail is what I'm looking for. Equals to. Select the max retail from books. Here you go. These are the authors of the most expensive book. Everybody got this?
Yep.
Now a slight variation to this one. Do this query. Everybody got this done? Cool. So what do you do here? What changes did you make to this query?
I just concated a comma, a space, and then the first name to last name.
That's it. As full name. So as you can see, the concepts that you learned before, oops, I should use single quotes, not double quotes. So the concepts you guys used before, learned before, keeps coming back. And you can always add them to your existing queries. Now, the next one I want you to solve is where you look for one record based on the reference of another record. For example, management needs to know the title of all books published by the publisher of the book Big Bear and Little Dove. So whoever published that book, I want to know other books that came from that publisher. So guys, what did you do in your inner query?
I selected the publisher ID from books where the title equaled Big Bear and Little Dove.
Okay, and then what do you do in the outer query?
Just inner join that to the publisher table, and then select the title.
Inner joined it?
Yeah, so books inner join publisher on the pub ID.
Well, doesn't the books also has a pub ID as a field?
Right. I joined the two with the pub ID.
Oh, okay, okay. So you basically said, I want to select the title of all the books where pub ID equals to, and where did you use your join?
Oh yeah, you could have done it with a where. That would have been simpler. I put it from books B inner join publisher P on B pub ID equals P pub ID.
Ah, okay, okay. Well, you could have done this too. It's much
Yeah.
easier that way,
Yeah.
where you
I
are
did that.
returning the pub ID of this book and then selecting all the books that have the same pub ID. Though that way you can just work within the same table. Don't have to go to multiple tables. How about the rest of you? Did you guys do it this way or did you guys do it a different way?
I did it your way.
Yeah, I did it that way too.
Now to the same query. If I add the following that the management wants to know all of the books that are published by the publisher of the following book and that generate more than the average profit return by all books. So William, Ronan, and Cameron are still working on this. So what did you guys do, those of you who are done?
I added and retail minus cost is greater than select average retail minus cost from books.
So basically something that we did in one of the queries above, right?
Yeah, exactly.
Okay. Now tell me this, that I will give you a query and tell me if this, or let me say, I'll give you a problem. And tell me if this problem requires a nested solution, a nested query solution or no.
That shouldn't, because you're just selecting the category and the profit in the category. If you just group by, you wouldn't need a nested one.
Okay, okay. Go ahead. Everybody go ahead and write the solution to this.
Alright, we do have to round it though.
Oh, don't worry about that.
Oh, okay. It does work.
Something like this.
Yep.
How about this query? Will this require anything in that regard that you have to do a nested query?
Say again?
Will this require a nested query as well, or no?
I don't think so.
No? Okay, so what should
Me
we write?
neither.
Just group by and then you have the where category equals literature.
I'm not interested in displaying the category. I'm only I'm only interested in displaying just the average profit.
Then just knock category out of the start of the select and then just add the where clause at the end.
Okay, go ahead. Write the query for this one.
Is it just me or does all of this class revolve around the select command?
Select command, as I told you guys at the beginning of this course, is the most used command, because a lot of the time you're pretty much retrieving the data. All your reporting and everything else revolves around the selects. Select is the most complicated command.
Oh, actually, the where needs to go before the group by.
Do you even need the group by?
Probably not.
Because you only have one category to select, which is
Right.
literature. So select the average of retail and cost, which is average profit from books for the literature category. Okay. Now, the reason I made you guys do these two queries individually, because you will need the knowledge of these to solve the next problem. So I wanted to discuss these two pieces individually with you so that you can figure out how you can use these pieces in this query to solve this problem. So one person is done so far.
Having trouble with the column alias.
That's okay. Yeah, I mean, like it's there for you guys to try. Just wanted to make sure. That's okay. Take your time.
Yeah, I don't really know how to solve this. I'm very close. It's just I can't seem to use the column alias in the having.
Okay, okay. How about the rest of you? I know Oscar got it, but Christina, Mason, William, Thomas, Cameron, where are you guys in terms of working on this?
Probably the same ballpark.
Okay. I mean, like, where exactly? Like having issues in having clause? Is that where you're
Yeah.
stuck to, Thomas and Cameron?
Yeah, I mean, as far as I know, I think I understand the logic. It's just getting it to actually work.
Okay,
Same here.
okay. Christina? Oh, okay. And William and Ron, and where are you guys? Mason and William? How far did you guys do it? Okay, maybe they stepped away. I hope they can hear me. Okay, so we want to display the list of all the book categories and average profit for each category. So here we have select category and average profit of all categories. So this far, everything is exactly the same as before. Okay. So display list of all book categories and average profit for each category, for all those categories where the average profit is higher than. Now that's the part. So since we want to remove after grouping, that's why we are using the having clause. Having what? Having the average profit higher than, and then we have a nested query. Having average profit higher than what? This guy. That's it. Right now, so we have a category average. Having average cost greater than. So that gave me all of them. Out of all these, I want the average profit to exceed. What is the average profit of literature? That is 28. And oh, and because nobody has an average profit exceeding 28. That's why it came out with nothing. Because the literature has the highest average profit of everybody. So that's why when I ran this query, the query works, but then there are no output because nobody matches the criteria.
Why didn't I think to just redo the column, whatever?
So what is it that you were trying to do, Christian? That your alias?
I was just trying to use the column alias as the average and the having instead of doing the calculation twice.
Oh, okay, okay, okay.
And I had the having in the group by swap.
Okay. So having always comes after group by, and where clause always comes before group by. So the sequence is from, where, group by, having, order by. You can skip items in the sequence, but from is required. Besides from, everybody else, you can skip them, but you have to maintain the sequence. Like in this one, we skip where. Any questions?
Not really.
So those of you who are in the middle of working, are you guys done with this query or still coding? Christina, William, and Thomas. Okay, Christina got it. Okay, Thomas got it. Okay, William. William, were you closed before? Just read your comment. Okay, guys, let's take a break here till 9:45. And then we will resume at 9:45.
All right.
So I am putting the query over here. I'll share, I'll put it in the chat. And let's set aside 12 minutes.
We're doing the quiz, right?
No. I've given you a query in the chat to solve in a group.
Oh. Oh, okay.
Okay. So what did you write in the innermost query?
The innermost query was select some set as an alias for books and order items. So b dot retail times order items dot quantity dot oy dot quantity.
Okay.
From
You said order
from
items.
Yep, oy. I alias that to
Books.
oy.
Where
Spell
order-
quantity wrong.
Oh, thank you. order items.isbn equals to books.isbn.
ISBN. Yep.
Anything else?
And then I grouped that by order number. Where the order number, well, I did an inner join, so having order number 1008.
Couldn't we just do an and? Because order number.
Yeah,
is
but
right
I
there.
used inner join.
Oh, okay, that's fine. So that is the inner query. Let's come to the outer query. So what fields did you select from the two tables? Let me copy this from clause. Okay. So what fields did you select?
I just did order number and that repeated the sum quantity dot retail. Quantity times retail.
Right? Okay, and anything else after the where clause?
After the where.
So I mean, like after the from clause, from.
Yeah.
Yeah.
And then
after this.
group by order number again.
Okay, group. Oops, group by order number. Okay.
And then having again the sum of quantity times retail greater than that inner query.
So basically, you were determining here which orders had a higher total amount due. The total amount was calculated using quantity times retail. So total amount is, and the order number is what we're selecting, grouping by order number, because there are multiple occurrences of the same order number in the order items table. So we are or grouping them by the order number. So for each order numbers group, we will have the order total. And then we are setting to see which order total exceeds the order total of the order number 1008. Yep. Okay, so let's run this one. Oh, quantity, not quality. See, Cameron, I need you to tell me. It would, oh, quantity, I misspelled quantity twice. Okay, here we go. So we have all these order numbers. Let me alias this, it makes a little bit more sense. There we go. So we have the total amounts and the order numbers grouped. And these are all the order numbers. Having the sum exceeding 1008 order number. So we are missing a few order numbers besides 1008, as you can see in the list. We're missing 1035, 1015. And I think there are some order numbers after 1018 as well. So for example, select distinct order number from order items. Yeah, so we have up till 1020 order numbers. So there were some order numbers that were not selected. Next, I would like you to open your books and go to chapter number 9 in the book. The chapter is about subqueries. One of you have Kindle, right? Or an electronic book format?
Yeah, I've table of contents though.
Okay, so chapter number 9. So in Kindle, how many pages is this book? Like 1,000 pages?
I have 836.
Okay, so in the physical book, we have up till page 487. It isn't too bad. Maybe it splits page in half and creates a
What
page.
it does is that each section gets its own page.
Oh,
like,
okay. So
Later on, like the thing that says multiple row subqueries, that is literally just one page for the one sentence.
I see. Okay. So chapter number 9, was everybody able to find the very first page, which is about the subqueries? At the bottom of page number, the very first page, there is a title or heading called single row or single value subquery. A single row or a single value subquery is a nested inner subquery that uses the single row operators like greater than, equals to, less than, equals to, and stuff like that, and returns only one row from the inner query. It is used when the result set of the outer query is determined on a single value from the inner query. So all the queries that you have done for the most part were single row or single value subqueries, because from the inner query, you were only getting a single value to the outer query that you were either using equals, greater than, less than, and all those operators to work with. And then it says, for example, what if we want a list of employees from the employees table for whom the employee salary is greater than the average salary for all employees? This would require 2 queries. Query number 1, where you determine the average salary for all employees, and query number 2, where you determine which employees have an above average salary. So here in example number 1, figure 9-1, the author shows you an example of where you're grabbing the average salary from employees. And then if you look at page 251, example 2, figure 9-2, where the author says, I want to select an employee ID, the last name, and the salary from employees, where salary is greater than that amount. So he hard-coded the value. This could be okay if you're only doing it a one-time deal, but it is not okay if you are to do this for dynamic content or changing content. So the better option would be to turn to page 252, figure 9-3, where he puts the example 1 and example 2 together, and he puts the example 1 as an inner query and example 2 as the outer query, again talking about a single row or single value subquery. Okay, can you guys test this on your end? Example 3 only.
Yep, that matches.
So can everybody give me a check when you're done testing this? So in all these cases, it was about a single row subquery. Now let's turn to page 253, where we have a multiple row subquery. A multiple row subquery is a subquery that uses the multiple row operators in any and all and returns more than one row in the result set in the outer query. So the inner query doesn't return the single value, but rather returns more than one values to the outer query. So the operator is greater than, less than, greater than equal to, less than equals to, not equals to, they all fail because they only work with a single value. So in those cases, you would have to use an operator like in or any or all to work with the collection of values coming in from the inner query. For example, the in operator is used in a multiple row subquery. The inner query returns multiple rows in the result set. The outer query then uses this list to determine whether the current row being processed is found in the list generated by the inner query. So the example given in the book is where we wish to create a list of employees who have a salary equal to the highest salary of any department. For this request, a list containing the highest salary for each department is generated by an inner query. Next, the outer query uses the list to determine whether each employee's salary is equal to any one of the salaries in the list. Is everybody following it so far?
Yeah.
Okay. Now look at the example number 4, page 253, where it says select the maximum salary from employees where the department code is not null, group by department code. So this query is only to show you what are the maximum amounts in each department. This is not an inner query. It is not an outer query, but this will become your inner query when you start joining things together. Now let's turn to page 254, example 9-7, where we start putting the two pieces together. Now we are selecting the last name, the salary, the department code from the employees table, where salary in, that means salary could be any one of the maximum salaries from any one of the departments. So this is where you would use this kind of an operator for multiple row subquery. So go ahead and run example number 5, and then give me a green check when you guys are done running example number 5. So don't forget to give me a green check when you guys are done. Okay, now moving on to page 255. Let me clear all these feedbacks. Page 255 talks about all and any. Those are the two keywords it talks about, or operators that can be used with subqueries to produce a single column of numbers. If the subquery is preceded by the all operator, the resulting condition is true if it satisfies all values produced by the subquery. If the subquery is preceded by the any operator, the resulting condition is true if it satisfies any values produced by the subquery. So now, for example, the all operator in example number 6. The example in figure 9-8, customers rows that have a discount greater than all Albany customers. So what the inner query does, it selects a discount from customers who are in Albany, and their discount is not null. So it will list all the discount rates. And now in the outer query, you are selecting all those customers that have the discount rate greater than all these discount rates. Now, somebody will say, well, I could easily solve the same problem by using the max discount, right? But that's not the point here. The point is we are using this example to learn about all operator. So test this query first, page number 255, example number 6. Okay, so as you guys are done with this one, this was about working with all operator. Now moving on to page 256, which talks about the any operator. The any is a similar query using the any operator is shown in example number 8, which is figure 910. And what this does is over here, it's same as requesting all customers that have a discount higher than the lowest discount, pretty much. That's what it means. So it means a value that is greater than all values would pretty much mean that greater than the minimum most value. Again, this could also be solved with a min operator, but that's not the point here. The point is to see how you can work with a collection of values. So all you need to do is make a slight change to your previous query, change your all to an any, and then run the same query again. So this pretty much takes care of the topic of working with multiple row subqueries. So we have covered 2 topics so far in the subqueries: single row subquery and multiple row subqueries. Next, we will look at page 258, which is about correlated subqueries. So in the previous subqueries, SQL evaluated the subquery once, substituted the result of the subquery in the search condition, and then evaluated the outer query based on the value of the search condition. These type of subqueries are called uncorrelated subqueries. A subquery can be used where SQL may need to reevaluate the subquery as it examines each new row in the where clause or group of rows in the having clause in the outer query. And this type of subquery is called a correlated subquery. So what you're doing is you're constantly reevaluating it. So a correlated subquery is a select statement nested inside another SQL statement, which contains a reference to one or more columns in the outer query. So far, we have not done any inner query, where an inner query will be referencing a field in the outer query, right? But this time we will be looking into something like that. So here, it's a select statement nested inside another select statement, which contains a reference to one or more columns in the outer query. So if you look at figure 9-11 on page 258, it gives you the difference between uncorrelated and correlated subqueries. And then let's turn to page 259, example number 9, figure 912. Now we are listing all the employees in the employees table whose salary is greater than the average salary of their department. Okay, so notice. So what we're doing is we're selecting an employee ID, a last name, and a department code, and a salary from employees. Done. The alias is EMP. Now, where the salary of each employee must exceed the average salary of all employees. However, look at the where clause in the inner query. The inner query where clause is where the EMP.department code. Where is the EMP defined? In the outer query, where the department code of the outer query matches the department code of the inner query. So you have created 2 copies of the same table, employees, one with an alias EMP, one without the alias EMP. The inner query is now referencing the field in the outer query. So this kind of a query would be called a correlated subquery. Does that make sense to you guys?
Your internet is cutting out a bit.
Oh, okay. Let me turn off the video. Okay. Is the sound better?
Yeah, but
Okay. Okay. So let me start again.
never mind.
Oh, is cutting out again?
It is.
Oh, okay. Let me do this. Let me stop sharing. Is this any better?
For now, it is.
Okay.
For me, you ain't cutting out.
Maybe it's just my internet then.
So how about the rest of you? Am I cutting out? Or I was cutting out?
Not
Yeah, you
cutting
were a
out
little
anymore.
bit, but it's better now.
Okay.
Yeah, much better.
Okay. So where did I started cutting out? So I'll just talk about it again.
Just after you explain the correlated subquery.
Okay, so when I was talking about example number 9, did you guys hear that?
I did not.
Okay, so example number 9, page 259, figure 912. This is the example where we have the correlated subquery, and this correlated subquery allows you to tap into the field in the outer query from within the inner query. So in the inner query,
Is he cutting out for anyone else too?
Yeah, you're
just
cutting out
keep
for me
going.
as well.
oh, okay. How about I try to reconnect? Let me end this and I'll be back. Okay,
Okay.
let me do that.